Alright, lesson 109, bisectors and line relationships. It looks like there's a lot of objectives that we're going to cover here, but most of it's going to be done whenever you're reading through the LMS or when you're actually working on your problem sets. It says define and construct perpendicular lines, segment midpoints, and angle bisectors. Notice the word construct. Of course, I can't do that in a CC. You may have to watch some extra videos or just do a lot of practice yourself and follow the instructions in the LMS. You're going to make geometric conjectures, and conjectures may be a new word for you. Use compass and straightedge or technology to test conjectures, and that technology is going to be GeoGebra. Then you should already have that downloaded. Describe and name points, lines, and planes. Understand the difference between a postulate and a theorem and how proofs are used in Euclidean geometry. Measure segments and angles, classify angles by their measures and identify special angle pairs, and use a compass and straightedge or technology to perform constructions. Some terms that you're going to be learning in this lesson are angle bisector, conjecture, midpoint, perpendicular bisector, and segment bisector. First thing we're going to talk about is midpoints. Midpoints are often confused with bisectors, so let's talk about it. I like this little graphic because he's talking about midpoint and he says, I'll meet you halfway. Well, this segment right here is 10 foot long, so obviously halfway is going to be 5 foot for each one of them. This little guy right here says, we are 10 feet apart. So once they've both gone 5 feet, then they're going to meet at the midpoint. So hopefully from that little graphic you've learned that a midpoint is a point that divides a line segment into two congruent parts. So you see right here in the word point, so a midpoint is a point and it divides it into two congruent parts. I put a segment down here for you, segment AB with M as the midpoint. This is how you would write it. You would say segment AM is congruent to segment MB, or the measure of AB equals the measure MB. And I just want to remind you that measures are equal, figures are congruent. Okay, so when you know the actual measures, they're going to be equal. If you don't know the measures, then the figures are going to be congruent. And another note down here is M is the exact middle of segment AB. Now talking about bisectors. The midpoint of a line segment divides a line segment into two congruent points. Okay, so sort of the midpoint is a bisector. A segment bisector is a line segment, or ray, right here underlined it in red, that passes through the midpoint of a line segment. And you can see a picture of this right down here. M is going to be your midpoint. Line T, line N, line S, they're all lines that are segment bisectors. They're passing through the midpoint. The other thing that we're going to talk about is a perpendicular bisector of a segment. If you look, line N passes through the midpoint, and it's going to be your perpendicular bisector because when line N crosses through that midpoint, it creates a right angle with segment AD. So that's going to be your perpendicular bisector. Now let's talk more about bisectors because I really want you to understand them. Here's an illustration of an angle bisector, and notice these little arcs with the dashes on them, or little tick marks. Those are telling you that each of these smaller angles are congruent. So that angle bisector divided this angle exactly in half. When you have a perpendicular bisector, you've got here segment AB, and you've got segment CD is intersecting at the midpoint D, and it's a perpendicular bisector. So that means AD is going to be congruent to DB. And then down here in this illustration is a segment bisector. Of course, you've got the midpoint M, that's a segment bisector. Then you've got this line, and it looks like, we can't assume anything, but it looks like it could be a perpendicular bisector. But since they don't put a little box here, we can't assume that. this may have a measure of 91 degrees or 89 degrees, so we can't assume that it's a right angle. And then over here, I just wanted to show you a different illustration of a line going through point M. This is also a segment bisector, although, excuse me, it's not going straight up and down. So let's look more at the segment bisector. A line segment or a ray that passes through the midpoint of a line segment. So here's a segment bisector with a line. Okay, both of these illustrations show a line going through the midpoint. Now here's a segment bisector with a ray. Okay, it's starting out at the midpoint and then shooting up, and the same thing here, except this particular ray also is perpendicular to the segment. So it's not only a segment bisector, it's a perpendicular bisector. Now let's talk about these perpendicular bisectors a little more. A line that is at the midpoint of a perpendicular and perpendicular to a line segment. Help if I could read, huh? So here I have segment AB, and then I have segment CD that's perpendicular to AB, and I know it because they put the cute little purple box right here. Okay, I know it's a bisector because they're telling me AD and BD are congruent, so that means it's being bisected. Talk a little bit more about an angle bisector. It's a line segment or ray that divides an angle into two congruent angles. So this red line right here is going to be a ray. Looks like I'm going to call it ray 0A or 0A OA. Ray OA is the bisector. The original angle was 60 degrees. The bisector cuts it exactly in half, so now each of these smaller angles is going to be 30 degrees. Here's a segment that's bisecting an angle, and here's another picture of a ray that's bisecting an angle. And you will see lines bisecting as well. Oh, look, I showed you one. Constructing an angle bisector. Now this is a picture, and no copying of pictures. It won't work. But after you do construct an angle bisector, this is somewhat what your construction, these red lines represent your pencil lines that you should see. Instructions for this construction can be found in the LMS Lesson 109 and in the student guide. And I think I also have some video links that you can watch to see how to do angle bisectors, and if all else fails, you can do a search on YouTube. You might find something neat on your own. And I highlighted in yellow down here, you will be required to do constructions on the unit test. So be practicing them. Let's talk about a conjecture. A conjecture is an educated guess based on observations. So all this means is that you're making an educated guess based on a whole bunch of specific examples. Okay? Using your student guide and the GeoGebra link located on page 13 in the LMS, Lesson 109, I want you to investigate conjectures. So we've already defined it, and it says, for example, in the diagram below, we are given that line AX is perpendicular bisector of segment CB. It looks like AC equals AB, but that is only a conjecture. It may or may not be true. So what they're saying is that this segment right here, oh wait, I'm going the wrong way. They're saying this segment right here, AC, looks like it's congruent to this segment AB, and it really does look that way. But right now, we're just saying, hey, it looks that way. We have no proof, okay? So the conjecture is AC is equaling to AB. Until you prove it, it's just a conjecture. So let's look at this one. It says, if ray BX bisects angle ABC, which of the following is true? Let's look at A. If the measure of ABX equals the measure of XBC, so let's look at where these angles are. The measure of angle ABX is equal to the measure of XBC. Well, that's going to be true because they told us that BX is a bisector. Ray BX is a bisector. So A is going to be true. So let's look at B. It says the measure of ABX is going to be half the measure of angle ABC. Well, that's also true. Because BX is a bisector, AXB is going to be exactly half of the larger angle ABC. Now let's look at C. I'm betting D's the answer, but let's look at C first. Half the measure of angle ABC, if I took half of it, will equal the measure of angle XBC. That's going to be true also because they told us that ray BX is a bisector, so that means that the measure of angle XBC is going to be half of the larger angle ABC. So D is all of these. They're all true. Let's look at some other examples. It says, can you tell from the figure that line ST is perpendicular to line GH? Well, here I go again. I like to mark what they're talking about. So line ST, they're wanting me to state if it's perpendicular to GH. So there's the lines I'm looking at. And I can tell you for a fact that they are perpendicular because in the figure, this little box right here tells me that there's a right angle involved. And remember, perpendicular lines are formed with right angles. Okay? And I can also tell you over here that BC is also going to be perpendicular to GH because of the box. So there's the answer. Yes, line ST is perpendicular to GH and line BC is perpendicular to GH. Now, can we also look at this same figure and determine that line BC is parallel to ST? So let's see what they're talking about. BC, ST. Now I can tell you that yes, they are parallel because BC is perpendicular to GH and ST is perpendicular to GH. So that means they have to be parallel. And there's the answer, just like I told you. Alright, this one says construction, copy an angle. It says draw ray DH similar to the bottom ray and angle Z in the figure. Then use a compass and a straight edge to construct an exact copy of angle Z on segment DH, or ray DH. So I'm going to try to web share here and see if I can show this to you. An example. Well, hold on, that's not working. Maybe I got to put it over here. Let me go back. Well, you know what? You can probably see it since I'm recording. That was kind of a duh moment. Let me push play.
An angle. Step 1. Draw an angle like angle P on your paper. Use a straight edge to draw a ray on your paper. Label its endpoint T. Step 2. Place the point of the compass at point P and draw a large arc that intersects both sides of angle P. Label the intersections Q and R. Step 3. Using the same compass setting, put the compass at T and draw a large arc that intersects the ray. Label the intersection S. Step 4. Place the point of your compass on R and adjust so that the pencil tip is on Q. Step 5. Without changing the setting, place the point of the compass at S and draw an arc to intersect the larger arc you drew in Step 3. Label the point of intersection U. Step 6. Use a straight edge to draw ray TU. You have copied the angle.
All right. hopefully we were able to see all that. Let's go on to the next slide. Alright, whenever you're doing a construction on the test, you're going to have to do the construction showing all of your little pencil marks like this right here. Okay? Over here, and also whenever you do a construction, they're going to ask you the steps that you use to do the construction. So this right here is a good example of what you'll be expected to do on the unit test. You will be required to record the steps. Constructions must be done by hand, so practice, practice, practice. But it goes through and it explains to you, and that video was a good explanation as well. Step 1, what did you do? Step 2, what did you do? Step 3, and so on to do the construction. That's exactly the way it needs to look on the test. Okay, and there are some links that are going to help you with all the constructions in lesson 1.09. So what we did talk about was a segment bisector passes through a midpoint of a line segment and divides it into two congruent line segments. If a bisector forms a right angle with the segment, hey, then it's perpendicular. An angle bisector divides an angle into two congruent angles, and a conjecture is a statement that is believed to be true, but it still needs to be proven. It's an educated guess based on observations. What you should be doing after you watch this video is reading the LMS lesson and following those instructions and completing your student guide. You need to be reading pages 15 through 18 in the reference guide if you haven't already, and complete these problems. Most of these problems, that's the reason I haven't had a lot of examples, are actually constructions, and you really need to work on them to get the practice. Contact me or attend TOGA if you have any questions before completing the 1.09 mid-unit test. You will be able to do corrections on the mid-unit test, but there will not be any retakes. But please make sure you're understanding the material before you take the test. Make note of any general questions you may have when you attend CC on Thursday. And that's the end of this lesson.